Okay, so we talked about waves, right? And we gave a few names to different things in the wave pattern. Like we said that there is a frequency, there is some uh, amplitude, displacement, which are all measured from the this baseline, the rest position of a wave, right? And then we said that the maximum anything can go from this base position. This was the maximum, that was the amplitude. And if it wasn't maximum, that was simply a displacement, right? So for example, in this case, then we said that there are two kinds of waves. There's the mechanical wave and there's the electromagnetic wave. In mechanical wave, what is fixed is frequency, and in electromagnetic wave, what is fixed is speed. So everything else just works around it. The basic formula is V equals to F lambda. But because speed is fixed in one, frequency is inversely related to lambda. And in mechanical waves, velocity is directly related to wavelength because frequency does not change, it's constant. Frequency, we defined it to be 1 over t, which basically means the number of waves passing per unit second or per unit time, basically. So it was, so if something, the unit was hertz, so 5 hertz mean there are 5 waves per second. 10 hertz mean there are 10 waves per second. 10 gigahertz mean 10 billion waves per second, right? So that's how it goes. So this was the wave, the basic pattern that we talked about. Then we said that there's a thing called being in phase. So particles that had the same displacement, same direction from the rest position, they were in phase. So any 2 points that are in phase, we find how far they are, and that's wavelength. And we find how much time it takes for wave to get there. So that is the time period. So lambda over t comes from there. So lambda is the distance between two consecutive points in phase, and time period is the time taken for wave to travel from one point to the next point in phase. So that's how these are. So we went through all of this. All right. And then we briefly discussed the role of water waves. Okay, so what are a few things that waves show? So there are some things that all waves to some extent show that. And the first one is reflection. So what exactly is reflection? Reflection is when a wave hits something and from there that wave comes back. Obviously, we are assuming all of these things to be 100% efficient. So right now, when we talk about reflection, we will not talk about how reflection is mixed with something else and there's a loss of energy. There does occur a loss of energy. So the basic idea here is that if the wave is coming, and what I'm going to do is I'm just going to show one straight line to show as a wave. Obviously, this is not the wave itself. Waves तो इस तरह से होंगी ना, ठीक है? But this is supposed to show the direction of the wave. So that's what happens. So let's suppose there's a wave coming in. Obviously, it's going to hit something. So let's suppose this is a surface from which it is going to be reflected. So when this comes here, what happens is that this is going to intersect or touch it at an angle, and that angle is this one. But what we do when we are measuring waves and when we are dealing with them is we don't measure this angle. We in fact measure the angle that is to this perpendicular imaginary line to the surface. So this perpendicular line, we call it normal. Okay. So every wave, we are going to measure the angle from the normal. So for example, for this wave, this will be our angle. And this is called incident angle, that this is where the wave is coming in. Now, when it comes here, and obviously it cannot further pass through this medium. Let's suppose these lines are supposed to show that it cannot pass into the medium. Then it's going to reflect, obviously. How does it reflect? The rule is really simple. The rule is that incident angle is the same as reflected angle. So what it basically says is that it's like a mirror. The angle at which it is incident is the same angle at which it goes back. Okay, so that's exactly how it goes. So it goes like this, and the angle here, this angle, again measured through the normal, this is reflected angle. So incident angle, reflected angle, and they're both the same. Okay, the third idea is that there is no rotation happening. So when a wave comes in, it does not rotate in any way. So it's not like that if I had a 3-dimensional diagram, then it would come out or something from this screen. Aisa nahi hota. So we say that the incident ray, reflected ray, and normal all lie in same plane. What it's supposed to tell me is that there is no rotation of any kind happening. So not only is the incident angle same as the reflected angle, there's no rotation happening, which means कि वो wave आएगी और उसी तरह से वापस चली जाएगी. ठीक है? So that's reflection. Obviously, it depends on the medium. Some medium allow the wave to be reflected completely. Some medium absorb some of it and reflect some part of it. So we experience that all the time. Different grades of glass reflect and absorb light differently. So if you can see a reflection, obviously a mirror is the best one because it's reflecting the most, but you can also see some see-through glass that does reflect at some angles. And we will talk about what angles are those where it starts to reflect. So the second thing that waves do is called refraction. And refraction is slightly different from reflection and absorption. So in refraction, what happens is that when you have a medium, and this is a medium in which wave can pass through. All right. So it is not a medium that lets it go away or all that. It's something that we might call, for light waves, we might call it transparent. Okay. That the thing is going to pass through it. So let's suppose something comes here. So this is the light wave coming in. It's going to pass through. But the thing is, it doesn't go straight in. What it does is there's some sort of bending that happens with the wave. Why exactly does that happen? It has to do with the density of the medium. So for example, if the medium is very dense, then the wave has to pass through it, and it has to pass through those atoms and make way for itself. And obviously it will be slowed down because there's high resistance that it's facing. And because of that high resistance, the wave is slowed down. But you know that light wave, for example, the speed is fixed in a medium, right? So to make do with that speed, it has to change its lambda. It has to change its direction to some extent, ताकि distance उतना ही लगे, frequency उतनी ही लगे, लेकिन उसकी speed कम हो जाए. To accommodate for that change in speed, it bends, it finds a shorter or a longer path. Because अगर speed ज़्यादा हो जाएगी, it will take a longer path, and if the speed is reduced, it will take a shorter path. All right. So that is why the wave bends. अब वो bend किस तरह से होती है? It has to do with the normal again. So here the thing is that let's suppose this is my medium number 1. So medium 1, and this is my medium 2. Then let's suppose my medium 2 is more dense than the first medium. Let's suppose it's going into a denser medium from a lighter medium. So what will happen is that it will need a shorter path because its speed will be reduced. So if you want to reach somewhere in the same time, you will, and you're going slow, you will take a shorter path, right? But if you're going fast and you want to arrive at a certain time, it doesn't matter whether you take a longer path or not. That's exactly what light does here. Because it's gone into a medium that is denser, where it is going to be slowed down, that would mean that it needs to take a shorter path. So how does it take a shorter path? By bending towards the normal. So what happens here is that this angle incident and this angle refracted angle, they are related based on how much the speed varies. And this idea of how the speed varies, we call it eta, but in O levels, we don't call it eta. In senior classes, we will call it eta, but for now, we're just going to shorten eta to call it n. Okay, eta is basically this thing. All right, so we don't write that, we write it as n. And this thing we call refractive index. Now, how is refractive index related to speed? It's basically the ratio V2 over V1. So it's basically how much the speed is reduced or increased. Okay. And this is directly related to sine theta 2 over sine theta 1. Now, don't take me wrong. How am I getting this sine theta here? Like, kahan se aa gaya? So for that, we have to learn a little bit of trigonometry. Okay. So think about it. You're getting this wave. Okay. And you want to measure how much of this wave is going to come in, or how much of this wave is parallel to this medium that I have. So what do? You can make a triangle here, right? Right angle triangle. Do you see this right angle triangle? Now, if I know this wave, again, this is my velocity of the wave. I wanted to find this thing, this length, how much of it is parallel to the medium. Then using this triangle, how do I find that? You have studied sine, cos, and tan, right? So if I said sine of I, what would that be? That will be x over v, right? So that will be x equals to v2 sine I, right? So that is how we find this. Similarly, if this was bent over here और मुझे ये वाली side चाहिए जो कि इस angle के opposite है, so I will do the same thing. It will be if this is x, so x will be v sine r, right? So that is where we get this. So you don't need to really know kahan se ye formula aata, but that was just a crude way of understanding. Obviously, there are a few other things that I missed out on very conveniently. But this is how it comes out to be. Refractive index is the ratio of the two speeds or the ratio of the sines. Now, how do you know which angle I'm going to put over here? So for that, remember that refractive index can never be smaller than 1. It's always greater or equal to 1, which means that the numerator must be greater than the denominator. So I know that many teachers would advise you to flip the ratio agar wo wave aa rahi hai ya ja rahi hai and all that. You don't need to do that. The definition of refractive index accommodates that in itself. So this side will always be bigger than this side. So for example, if you're taking light coming into diamond, for example, so the light coming from air into diamond, so diamond mein uski speed kam hai aur air mein uski speed zyada hai, so in that case this will be your velocity for diamond and this will be your velocity for air. Similarly, this will be the angle for diamond and this will be the angle for air. Okay, so just remember that for refractive index, which is basically going to tell us how two medium relate to each other, it's simply this. So let me take an example of glass. So let's suppose there's a glass that has refractive index of 1.5. What does this mean? It simply means that the speed in air is 1.5 times the speed in the glass. Or if the speed in glass is 2, the speed in air will be 3. That's what it means. So agar aise wave aayegi, so it's going to bend a little like that, and this will be your incident angle, this will be your refracted angle, और speed में कितना फर्क आएगा? 1.5 का फर्क आएगा. The speed in air is 1.5 times the speed in this glass. If, for example, you have refractive index of 2.5, that would mean the speed in air is 2.5 times the speed in that whatever medium you have. So for example, 2.5 could be for a diamond. Okay, so that means के diamond में जिसकी speed होगी, air में उसके 2.5 times speed होगी. ठीक है, या diamond का जो angle का sign होगा वो दूसरे वाले का 2.5 times होगा. Okay, so that is how this relates, and that is what refractive index is. It allows us to relate to medium. So for example, there was this really cool video that I saw somewhere. Let me find it. Yeah, so if you look over here, so these are some polymer balls that this guy is holding. N is a ratio, it doesn't have a unit. So notice what happens. That one has simply become invisible. There you go. It's completely invisible if you put it in water. So the guy is holding on to a ball right now, but you can't see it, right? Because it's underwater. But as it brings it out, you can see. So what exactly is the reason behind it? The reason here is that when light enters this polymer ball from water, you don't really see it entering like that. And the reason is really simple. The light doesn't bend. The only reason you're able to see light entering from one thing to another is when it bends, and you can sense that bending of the wave. You can see it refract. But if the wave simply passes right through a medium, even if the medium changes, what does that mean? That means to the light, it feels that there is no change in medium. Why? Because the refractive index is 1. That, for example, if this was water and this was the polymer, the refractive index was exactly the same for both of them. Okay. So that is why the ball, when they put it in water, it was invisible. क्यों? क्योंकि जो water का refractive index था, polymer का भी उतना ही refractive index था. And you can design these polymers in ways that you want the refractive index. The whole science of making glass revolves around it, that we want a certain glass to act a certain way. And for that, we have to deal with density and all those things, the material used to build it. So the refractive index is exactly what we want it to be. Okay. Now, obviously, why were you able to see that polymer in the air? It was because the polymer compared to air, it had a different refractive index. So just like water, so यहाँ पे polymer होता है या water होता है कोई फर्क नहीं पड़ता, because they both had similar density. तो इस वजह से हमें यहाँ पे नजर आता है. Now obviously the idea is that if the water and polymer have the same density, तो वो उसमें float करना चाहिए या उसकी surface पे रहना चाहिए. And that's exactly what happens when you make these balls. It's difficult to drown them without having extra force on them, क्योंकि वो same density होते हैं तो mix हो जाते हैं. ठीक है? So that's a pretty cool thing. You can design things that way. The question that I just received it, how do we know what medium refractive index is referring to? So refractive index does not refer to one medium. It's always a ratio of two medium. Okay. Usually all the values that we quote, they are related to air. Okay. So usme, what we do is we say, okay, the faster medium is the air and the slower medium is whatever medium we're talking about. So for example, if I say 2.5, then what I'm basically saying is that the speed in air is 2.5 times the speed in that medium. So the higher the refractive index, the higher the change in density. अब वहां पर बड़ा simple सा idea है कि let's suppose I know that there's something that has a refractive index of 1.5, which means that if air was this, then it will go like that. Okay, so that medium is denser than that. Similarly, if the medium was 2.5, so वहां पर bend वो ज़्यादा होगी. ठीक है, so वहां पर वो ज़्यादा bend होगी. So the angle will be even smaller. Okay, compared to this one. Now, what if I said that this was my air and this was medium 1 and this was air and this was medium 2? What would happen if I had medium 1 here and medium 2 here? What would be the refractive index of these things? So the idea is really simple. All you got to do is divide the refractive index of this thing, which is 2.5, with the refractive index of this thing, and that will give you 2.5 or 1.5. So if you had a interface, this thing is called interface, okay, where the two medium change, usko interface कहते हैं. So if I want to figure out their relative refractive index, I can just find it this way, that is going to be 5/3. But obviously O levels और IGCSE में वो ये बातें नहीं पूछते. O levels और IGCSE में we take the first medium to always be air. It could be air, it could be vacuum. Air और vacuum में बहुत ज़्यादा फर्क नहीं है. That is it necessary for n to be 1 so light passes through without bending, or does n have to be the same for both? N doesn't have to be 1, and the relative n has to be 1. When I was saying कि उनका n 1 है, that simply meant that I was saying that between water and polymer there is no change in the refractive index. Obviously water has a different refractive index than 1. उनका आपस में 1 होने का मतलब है that they're equal. वैसे obviously they will have some refractive index related to air, obviously. Okay, so that's the idea of refractive index. The second rule here, the first rule was simply this: the refractive index is the ratio of the speeds or ratio of this, and we call this Snell's law. Okay, this is a very simplified version of Snell's law. So yeah, the second one is again that there is no rotation, which means that the normal, incident ray and refracted ray all lie in same plane. Okay, so that's the idea here, that normal, incident ray and refractive ray, they are not rotating at any cost, so they are going to be in the same plane. So that is the idea of refraction. Obviously refraction helps us figure things out. That for example, if you look at water waves, you can easily see how the depth of water is changing. Why? Because in shallow water, waves are going to have smaller wavelength, which would mean that they are going to be slowed down. Because अगर थोड़ा distance travel करना है, तो वो speed भी slow कर देते हैं, so that the frequency does not change. In deep water, it's going to travel faster, so the wavelength is going to be bigger. What this would mean is that deep water can be considered to have lesser density than the shallow water, क्योंकि shallow water में refract होएगी and it will have a smaller angle than the deep water. So if you had an interface like this between deep water and shallow water, it will look something like this. Okay, so this interface, you can see that in deep water it's going to have a larger wavelength, a higher speed, and shallow water it goes the other way. Okay, the third idea that we have for wave is called diffraction. Okay, so for example, if this is a pattern, which is a pretty basic pattern, what happens here is that, for example, this thing. So what happens is that wave is coming in. This is a wave, and these lines are supposed to be wave fronts. But as soon as it enters this gap, so this is supposed to be a gap. So there's this wall, there's this wall. When it goes into this, the wave bends. It starts to bend a little bit. Now this is a wide gap. You can see it much more clearly if you had a narrow slit. So for example, if you had something like, yeah, if you see this, then this is a pattern where the gap is smaller and the bending is huge, right? So there's a much greater extent of this bending that's happening. Obviously, for this thing to work, what we have to do is that this gap should be comparable to the wavelength. अगर ये gap बहुत बड़ा होएगा तो bending उतनी ज़्यादा नहीं होगी. And if it is smaller than the wavelength, तो bending तो होगी नहीं, wave जा ही नहीं सकती इसमें से. So this is called diffraction. Diffraction is something that you just need to know about. इनकी ज़्यादा detail आपकी या कोई calculation आपके syllabus में नहीं है. What you just need to know is that diffraction is when wave bends when it passes through a slit. Okay. Where have we experienced it? So for example, you might have microwave ovens at your home, right? So inside, microwaves are passing through, right? But there is a mesh through which you can see the food rotating on that turntable, and you can see the food ke wo warm ho raha hai and all that, right? Why is that? Why don't those microwaves come out of the microwave? That is simply because of diffraction. Okay. What happens is that for diffraction to work, unki wavelength comparable honi chahiye. ठीक है? The angle at which it reflects should be comparable to the wavelength that they have. But what happens in microwave ovens is that mesh is much bigger. So wo wavelength of those microwaves is really small. तो उस वजह से वो उसमें से escape नहीं करती, वो अंदर absorb हो जाती. ठीक है? Another reason for that is that microwaves do not get absorbed completely into the metal. तो उसकी वजह से वो वहाँ से reflect होती हैं और उसमें से जो electrons होते हैं वो energy भी absorb कर देते हैं, तो it causes an explosion. That's why you should never keep a metal inside microwave. So that was a little unrelated. But diffraction, just you need to know that diffraction is a phenomena where the wave bends as soon as it passes through a slit. Obviously, that slit has to have some comparison to the wavelength that happens. Okay, so where do we use it? So for example, so a very useful application of diffraction is that you can use diffraction to slow waves down. Okay, and you so for example, when they were designing those Palm Jumeirah, there was this project in Dubai, and they knew that the waves from the ocean, as they came towards the harbor, they had energy, but obviously unko wo slow down to kar sakte hain by making it shallower, but those waves will eventually erode away the sand that they put in there. So they made these smaller gaps, and those gaps were basically these slits. मैं आपको एक example दिखाता हूँ उसकी, like this. So they made these small openings. So as you can see over here, that this thing is supposed to be a wall that the water waves cannot pass, and this is supposed to be a small slit. So when a wave comes in, much of it is absorbed by this wall, and very little of it comes in, and even when it goes in, it is bent and its impact isn't that much. So uski wajah se erosion was reduced. So that's one application of where we use diffraction to our advantage. Okay. So far we have talked about this basic theory of waves, and we have talked about the number one, there is the refraction. Second, there is refraction. Third, there is diffraction. Okay. The fourth one is interference. Again, interference is not in O-level syllabus. For IGCSE, you need to know that. So interference is again something that you have seen plenty of times. Interference ki example मैं आपको ये देता हूँ. So what happens is that you have two waves. Okay, so these are supposed to be circular waves, and what's happening is there's these two balls, they're bobbing up and down, and obviously one of them is acting as one source of wave and the other is acting as one source of wave, and they have these circular waves that are coming in. But what happens when these circular waves meet each other? They create a new wave with a completely different pattern. ठीक है? और आपको ये dark or light patterns नजर आते हैं. होता क्या है? For example, if there's a point where one wave is coming in that has a crest, and the other wave is also coming in that has a crest, सो दोनों ऐड हो जाती हैं एंड यू गेट अ वेव दैट हैज डबल द क्रेस्ट. ओके, तो आपको एक बड़ी वेव मिलती है. सिमिलरली देयर इज पॉसिबिलिटी कि एक वेव आए और उसका क्रेस्ट हो और दूसरी वेव आए उसका ट्रफ हो. तो व्हेन दीज टू ऐड यू गेट अ बेसिक फ्लैट वेव बिकॉज वहां पे वो दोनों एक दूसरे को कैंसिल आउट कर जाते हैं. This is called interference, where individual displacement of waves they start to add up. तो wave की जो भी at that particular position जो भी उसके ऊपर displacement होती है दोनों waves की वो add हो जाती है. ठीक है, just like any vector. So that is something that you see when multiple sources are acting. Where do we see it? So for example, if you had a phone and you started, let's suppose you played a certain song on it, and the other person also had a phone that had the same song and they were not in sync, तो आपको जो आवाज मिलेगी ना वो बहुत खराब सी होगी. You wouldn't be able to focus on one song from one source. वो दोनों का मिक्स हो गया, अजीब सी आवाज मिलेगी आपको. Imagine having both of them in sync. ठीक है, अब उससे क्या होगा? Let's suppose I think House Party or iPhone or something, they have this feature in them कि अगर दो सोर्सेस से एक ही टाइम पे एक ही गाना लेट्स सपोज आप प्ले करते हो, सो व्हाट हैपेंस इन दैट केस, बोथ ऑफ द स्पीकर्स दैट आर ब्लास्टिंग दिस सॉन्ग आउट, those two waves are going to add up to each other and you're going to hear a much louder song which will be in sync, right? That is because of interference. जब वो interference पॉजिटिव कर रहे थे, जब वो दोनों ऐड अप हो रहे हैं तो आपको एक लाउडर साउंड सुनाई दे रही है. जब वो दोनों इन सिंक नहीं है तो वो तबाह कर रहे हैं गाना. ठीक है, आपको सही तरह से आवाज ही नहीं आ रही है उसकी. सो दैट इज बेसिकली इंटरफेरेंस. द लास्ट pattern that waves show is polarization, and that is again something that isn't in O level syllabus. So polarization is when a wave comes in and we make sure कि wave, obviously wave different planes में आ रही है. एक wave ऐसे जा रही है, ठीक है, एक wave ऐसे जा रही है, ठीक है, एक wave टेढ़ी मेढ़ी ऐसे करके आ रही है. Different kinds of waves हैं, but we only allow, so we have this slit and we only allow a certain wave to pass through. उससे क्या होता है कि आपकी सारी waves जो कि randomized होती हैं वो उस तरह से नहीं गुजरती, वो एक ही slit में से एक ही तरह की wave गुजरती है. ठीक है, so polarization allows you to have only one angle or one plane of wave to pass through. It only works in transverse wave, doesn't work in longitudinal waves. ठीक है, so होता क्या है कि उन slits में से आप बहुत सारी different direction की wave आ रही है. So this is a representation of polarization. So what happens here is that this hand, it is producing these waves that are in all different directions, but only one will be allowed to pass through this slit, this B. And then if this is horizontal, अगर हम उसको rotate कर देते हैं तो वो भी pass नहीं कर सकती, तो आपको एक flat wave मिलेगी, यानी कि wave खत्म हो जाती है. So we use it when we don't want unnecessary reflections to come in. जैसे polarized lenses होते हैं, ठीक है, कि आपको एक ही डायरेक्शन की लाइट आनी चाहिए, दूसरी डायरेक्शन की लाइट ना आए, तो उसके लिए हम पोलराइजर्स यूज करते हैं. ठीक है, एंड दोज आर 5 main patterns or behaviors that waves have. There is the reflection, which is simply that the angle of incidence is same as the angle of reflection. There is refraction, which means that refractive index works and this ratio of speed is refractive index, which is same as ratio of sine. It can never be less than 1, and which means that the numerator will be greater than the denominator. And then you have diffraction, which is when waves bend when they pass through a slit. If the slit is smaller, there's greater bending. If the slit is wider, there's smaller bending. There's interference where waves add up just like any vector would based on any position. And there's the polarization where a wave in only a certain direction or a certain plane is allowed to pass through a slit and the other ones are not passed through. So I'll explain polarization again. Polarization is that you have these waves and they are in all different directions. Okay, so for example, if we take polarization of light, that you have this transverse wave and that has different angle at which it comes in. Now obviously the only if you have a slit like over here at B, it is only allowing a particular angle of waves to pass through. Any other angle that's going to come in will not be able to pass through this slit. मतलब आपको कोई random wave यहाँ से ऐसे करके आती हुई आ रही है तो वो block हो जाएगी, वो उसमें से गुजर नहीं पाएगी. ठीक है, the only wave allowed would be the one that is perpendicular over here, that is at the same angle at which you have put that slit in there. बाकी सब waves को वो block कर देता है, which allows us to isolate a certain plane of wave compared to all the other ones. ठीक है, so that is used when we want to have isolate a certain angle of wave or certain इसको ओरिएंटेशन कहते हैं, सर्टेन ओरिएंटेशन ऑफ वेव, उसको हमने आइसोलेट करना होता है, तो दैट्स वेयर वी यूज दिस, पोलराइजर्स को यूज करते हैं. ठीक है, yeah, so that is what the five main patterns of waves or five main behaviors of wave.